I'm Dan Mabey, CEO of Bighorn Oil and Gas, and I have here with me today Lloyd Blackburn, who is a geologist for our drilling partner here in the Bighorn Basin on this exciting prospect that is complex, but its uniqueness suggests that it has some very exciting large field potential. It's drilling into areas that are known producers. These gentlemen have drilled a lot of wells in this area. And the surrounding areas, and here in the West, obviously, when we say surrounding, we don't mean next door. We're usually 5, 10, 30, 50 miles away, but that's all close to us. But nevertheless, it's all on the same geological structure, and it's all on the same overthrust belt here in the Bighorn Basin, which is 2.5 billion barrel history of production, so probably the largest in the western United States. Lloyd, you've studied this. You're familiar with geology here, with a lot of wells you folks have drilled. I'd like you to spend a few minutes and just explain to us a little bit about this prospect, how it works, some of the geology, some of the elements that we've talked about in the past, so we'll have a little more thorough understanding about how we'll tackle a project like this and what the potential opportunity could be.
All right. Dan mentioned, I've been in the business for slightly over 30 years now. I worked for a major oil company for 23 years. Most of that time was spent up here in the Bighorn Basin and the other basins in the Rocky Mountains, as well as working some other basins in Texas and Oklahoma and Michigan and other places. But the bulk of my career has been spent up here, especially focused in the Bighorn Basin. And it is an exciting opportunity here because we are in the most mature basin that I can think of in the Rockies, and certainly the most prolific producing basin. That's the Bighorn Basin. And the Bighorn Basin has been producing for just slightly over 100 years now, but people are bringing in new wells all the time, and very, very attractive economically. If I could have you swing the camera over here. This is a map we've prepared, focusing mostly on the Bighorn Basin. The yellow area here is the surface expression of the Bighorn Basin itself. Down here is the Wind River Basin. This is the extreme northwestern corner of Wyoming. Right here, you're getting into Yellowstone National Park for reference. But as you can see here, hopefully you can on the camera, all the little blue dots here are existing oil fields. The very first oil field in the Bighorn Basin was found up here at Garland, and Elk Basin was an old one. But so far, this basin has produced 2.6 billion barrels, and I'd say about 98% of all the production out here was found from these big anticlines. Most of these anticlines are exposed on the surface, and 105 years ago it was fairly easy to map these things out. And I would say it took the industry 20 years to find the very biggest anticlines, and they did a wonderful job. But as late as the 50s, they were still finding undrilled anticlines that produced. It's been a little while since they've found any of these big monstrous anticlines, and so the industry in the Bighorn Basin, for the most part, for the last 30 years especially, has been focused on exploiting the reservoirs and these fields for the most part. And for the last 25 years, certainly, no one has made a concerted effort to go exploring for new fields in the Bighorn Basin. Yet there's tremendous opportunities out here for new structures. But you have to use a little bit different ideas. It's an old axiom in the business that you find oil in old places using new ideas, or new places using old ideas. This is an old place. We have a known hydrocarbon system in that we have an excellent reservoir out here. It's called the Tin Sleep. It's Pennsylvanian in age. we have proven oil generation capabilities out of the Phosphoria Formation. So, the cooking pot is out here. We just need to find more places where this oil is trapped, and that leads us to the Horton Draw prospect in particular. And this is a very geologically complex area. That's why I think it's been overlooked for the history of this basin, because it's in an area where the structures are slightly different in some respects as to the very simple anticlines that they found originally. If you can swing over here, we'll kind of zoom in a little bit. The area we're talking about is here in Township 45 North, 88 West. You know, the industry was interested in this area for quite some time, because there is a known anticline that comes out of the basin. It's plunging into the basin like that. So as you come up this known anticline, you can see all the dry hole symbols where people explored, mostly in the 50s, but all the way up until the late 70s. There were a string of dry holes that were drilled out here, and the problem that they faced was, how do you trap the oil? How do you keep it from continuing to come up out of the basin on this big anticlinal trend as you go to the southeast? And so we got to looking at that, and you know, the simple idea is you've got to find some kind of a barrier along this anticlinal trend that's going to keep the oil from migrating to the southeast. And we got to looking at it, and this is a final USGS topography map, and you can see the vegetation patterns here. There's a certain formation out here that is very prone to having juniper trees grow on its slopes, and those are in the light green bands here. And you can see very clearly that it's offset right here. You see these two bands here, and they come up and they're offset here. When you go out to the surface and look at this with your own eyes, you can stand on the ground and see it. It becomes real clear. There's an actual surface topography change here. And what I think is happening here, and in fact, I'm sure of this part of it, is you have this big thrust fault that's coming up here. That's the main direction of movement, is coming in from the west or southwest, pushing this plate up and over, and it's buckling, and you can see those rocks exposed, the younger Cretaceous rocks exposed on the surface, indicating that surface anticline. But I think in addition, what happened is as that plate was being pushed from the west and southwest, part of it moved fast. In the very early 80s, I think it was 81 or 82, another small company had come out here, and they had shot a small amount of 2D seismic data, and it's available to buy. You know, and so that's what we did. We bought what little data that there was out here in hopes that it would confirm, you know, the basics of what we were seeing on surface geology with seismic data. And this is one of those lines out of that grid here, this particular line up here. And it's going this way. So in a sense, if you're not familiar with the seismic data, you're getting a slice of the earth. And it conforms perfectly with what you can see on the surface geology. Here's various formations that I've interpreted here. In particular, this is the one that we're most interested in. This orange formation here, that's Tinsley. And Tinsley is accounted for probably 95% of all the production in the Big Horn Basin today. This is an aerial photo. And what's clear to me is, you know, you can see the big thrust fault that sets up all the surface topography. Intriguing is that you can see, you know, and you can see clearly the difference between these events here that are fairly flat lines, and then you come into this fault, and all of a sudden they're coming up and over, and they're bending. And so I was delighted to see this because, like I said, there's your Tinsley formation, a known, you know, a very good reservoir out here. and it was produced probably 2.4 out of that 2.6 billion barrel total in the basin. And so, you know, the basic concept of this is real easy, and it's confirmed on the seismic as it comes up. And then as the stress built up, as this plate was carrying it up and over the same formations over here, you know, it buckled and it turned over. And that's the trap in the east-west direction. What you cannot see on this line, because it's just simply a 2D slice, you cannot see these faults on there. So that's a leap of faith there, and that's what makes this area fairly complex. But that was the trap that we initially started looking for out here. And what was a surprise to me, though, I was expecting to see this, hoping to see it, and I did see it. That trap. What was underneath this main thrust, and I think that's the secret, and that's why we're really excited about this particular area, is underneath it we have a totally different type of structure. I think this is what some geologists would refer to as a flower structure, and that's set up by mostly transverse motion on faults. You've got this plate moving up and over. At the same time, you've got this motion that's going in a strike slip direction here. Now, that particular type of structure has never been tested. We've never seen one in Wyoming. But this does produce in various places around the world, all over the world. The one that I'm most familiar with is in the Arkoma and Anadarko basins in Oklahoma. And these are known producers and very, very big producers too, these types of structures. So that was a total surprise to me that you would get this. Now, granted, I've got a very limited amount of 2D seismic data, so it's kind of difficult sometimes to make meaningful maps. But what I've tried to capture is on these next two maps that I'm going to talk about. This one is showing the upper plate there, and these are the two strike slip faults. And you can see there's only a matter of, you know, somewhere around 500 feet of lateral displacement that separates this block from this block and the other block. Now the industry, they have drilled wells out on this the main trend, but they've all been to the northwest. Nobody has ever come down into this block because they didn't recognize the potential of this type of block. So what this map is showing is just based on my limited amount of data. You're coming up, and what I don't show because it would get really complex is where it goes up and over. This would be the crest of the anticline right here, and so you're sealed in this direction because of this the main thrust fault. You're sealed on each side by these other strike slip faults. Now, getting into the deeper play with this more complex structure, this is my idea of what it could look like. Now, granted, to have a sure shot or a better shot at a prospect like this, you would love to have a 3D seismic survey, ideally, or even just more 2D data, but we don't. We don't have that, and that makes the complexities a little harder to unravel. But what I've drawn here is my idea of what this thing could look like. And so you've got these three, they're pretty much going to be vertical faults in that sense, but realistically they're shifting this way and that way relative to each other. And what you form is in between these plates, as they're being compressed, they're all moving sideways, but you'll get little wedges that get squeezed together there. And so this could be a totally separate prospect here, and you know, it's difficult to come up with a realistically meaningful number on how many barrels could be in here. Well, could be zero, but these are the types of prospects that could really pay off big. I mean, this could be, you know, the next 200 million barrel field that we find in the Bighorn Basin. Either one of these could be, but I'm especially intrigued by this because no one has ever tried this type of a play in this